Good morning, students. Today's topic is regarding errors. What is meant by error in a measurement? It is an uncertainty in the measured value by humans using various devices. See, for example, I want to measure the length of a book. I am giving you a meter scale and ask you to measure the length of a book. I give the same meter scale to 5 students. One student may measure the value and tell me the value is 13.2 centimeter. The second person will take the same scale and the same book and he will say the value is 13.3. Other student may say 13.1. Some student may say 13.4 and so on. Different people will get a different answer. The whole number value will be same, but the decimal value can vary. The whole number value means 13. 13 will remain same, but one student may say 13.2, another student may say 13.3, another may say 13.4, like that. So the decimal part of a measurement is called the uncertainty. That value, the decimal value is uncertain. The other value, the whole number value is real. So the real value plus that uncertainty in the measurement, which is called error in the measurement. So we will get the values from different students. Say for example, 10 students took the reading and I collected the value of all the 10 students. I take the mean of that. The mean value of the 10 observations will give us the true value. Okay? The mean value, the average of all the 10 measurements will give me the true value of the measurement. Now let us discuss about which all are the different types of errors in a measurement. Errors can be basically classified into two. The first one is systematic error, second one is random error. Systematic error means error in a systematic fashion. That means there will be a specific cause for the error. We can identify that cause and we can rectify that error also. Because we already know the cause, we can rectify the error also. Okay? So systematic error, the error which will propagate only in one side. Either it will be in the positive side or it will be along the negative side. What I mean is, when I say 4.1, it may be 4.1, 4.2, 4.3. Either in that way or the error will be like 4.0, 3.9, 3.8 in a negative way. Okay? So either it will be in positive direction or it will be in negative direction. There is a specific cause. We can identify the cause. We can rectify the cause also. Okay. Now, the systematic error can be due to three factors. The first is instrumental error. The second is imperfection in experimental technique. And the third one is personal error. So, what is instrumental error? The error due to the instruments that we are using. Say for example, when I use a meter scale, if the edge of the meter scale is worn out, then we won't get the correct reading. Then suppose we are taking the meter scale but not a branded scale. So the readings that they have marked in the scale may not be accurate. So that is instrumental error. Now you can see this watch. This watch is a branded watch. It will show accurate time. But you will get the watches from the roadside. You can give 50 rupees or 100 rupees and buy watches. That watch will not show accurate time because the machineries which is created, the mechanics which is inside that is not genuine. So there will be an inaccuracy in the measurement. So there will be error. So that is called instrumental error. The second one imperfection in the experimental technique. You have a good you have a good device, but you don't know how to take the reading. For example, you have got with fever. You go to a doctor. Doctor will take the thermometer and put it on the underarm, and they will doctor will tell you to hold like this, and after some time he will take the reading. That way of measuring the temperature is not correct, because the temperature in our underarm will be lesser than the body temperature. So if the doctor measures the temperature like that, he will get a wrong reading and he will tell you you don't have fever, but actually you may be having fever. So you keep the thermometer in the below your tongue. That will give you the correct temperature. Or you have to keep the other part of the body which gives correct temperature is here. But keeping thermometer there is not possible, so we will keep it under the tongue. So that is imperfection in the experimental technique. Again, I will tell you, when you look the readings in a voltmeter, you have to close one eye, look straight to the voltmeter and get the exact reading. But instead of looking straight onto the voltmeter, one child is standing here. Voltmeter is kept here and he is looking like this with an angle. Then the value he gets will be obviously a wrong value. It is the imperfection in the technique. I can give you a third example also. While you measure the temperature of a bath, temperature of a water which is boiling, you have to keep the thermometer like this without touching the container. The thermometer's bulb should not touch the bottom of the container. That is the correct method. Instead, you are just putting thermometer like this and then say it like that. So, thermometer bulb is touching the container. The value shown by the thermometer is greater than the actual value. This is called experimental error in the experimental technique. Third one, personal error. Personal error is due to a person. The person knows how to take the reading, and the person have the correct apparatus also, but due to his negligence or due to his carelessness, he will take the reading wrongly. He knows we have to take the voltage reading like this normally, but he is very careless. He will stand like this and take the reading like this. It's personal error. Now he know how to keep the thermometer, but he is least bothered. He just put the thermometer like this and then take the reading as per his wish. That is personal error. So you understood these things. Now how will I correct the instrumental error? Always buy a branded one. And if the things has worn out, replace it with a new device. How to minimize this error? Learn how to take the reading. What are the experimental setup to take the reading? Then the imperfection in experimental technique can be rectified. Now, how will you rectify personal error? That can be rectified only by a teacher. Give the person a nice slap. Then all the carelessness will be gone, and the personal error can be rectified. Okay. So that's all about personal error. Then move on to random error. We don't know what is the reason for the error. There may be many factors. There may be voltage fluctuation, there may be change in the temperature of the surroundings, there may be pressure variation, there may be current variation, there may be wind. So, different factors can come together when we are doing an experiment which will cause an error. But we cannot identify which is the real factor, and all of them are occurring in random, in an uncontrollable manner. So, we cannot rectify it. So, what do? Is we will take the readings under different physical situations and we will get the answer. And we will take the average of that answer, which will give an approximate answer. Okay. Now, how will you find the mean absolute error? So every person, when they take measurement, he will be getting a value. He will be getting an error in the measurement. So let the first person took a reading, and the error he got is marked as delta A1. Delta A1. Error in the first person. Now second person took the measurement and he got the error. His error is delta A2. Similarly, I just took readings from n persons and the nth error is delta AN. So the mean absolute error can be written as delta A bar. It is equal to modulus of delta A1 plus delta A2 etc. delta AN divided by n. These two lines are called modulus. Modulus meaning whether the error is negative or positive, we will take only the positive value for our calculation. Okay, that is the meaning of modulus. These two lines are called modulus. So modulus meaning if you get a positive or a negative error, when we calculate, we will put only the positive values. Now, how will we find the relative error? So this is how you find the mean absolute error, and how will you find the relative error? Relative error is written as delta A. This is small letter delta. This triangle shape is capital letter delta. So small letter delta A is equal to delta A bar divided by A. Delta A bar is the mean absolute error and A is the true value. So I can give definition like this. Relative error is the ratio of mean absolute error to the true value. Okay. So that's all about relative error. And the third one is percentage error. Percentage error can be found by relative error into 100. Just multiply relative error with 100. You will be getting percentage error. Okay.